I'm trying to solve the mystery of gamma ray bursts, the world's most powerful cosmic explosions. Cosmic gamma ray bursts were a fantastic, complete, absolute mystery. All they were a little blip on a screen in a satellite measurement in time for decades, for several decades. They're so bright that you can see them across the entire universe. Currently, we're working on problems like, well, how do we measure more of them that are really from very far away in the universe? Remember, in the universe, if you look very far away, you're looking very far in time, back in history. So we want to use gamma ray bursts as a kind of probe, a kind of flashlight to light up these very dark corners of the universe. In fact, the universe, the first thing we see, can easily observe in the universe, is the time of the cosmic microwave background. That's something you probably heard about. A famous Nobel Prize-winning discovery of Professor George Smoot is some of the structure that you see by looking back in time at the time of the cosmic microwave background. Just after that, the universe, in fact, became transparent, and there was very little going on. It was dark. We call it the cosmic dark ages. A little bit later, stars started forming in the first galaxies, and then what we say happened is the universe became ionized, and we call this the cosmic dawn. In 2 sentences, my work is about trying to make a next generation instrument to refine our understanding of gamma ray bursts, so we understand gamma ray bursts in a very distant galaxy near the time of the cosmic dawn, and to discover the origin of short gamma ray bursts, which are the remaining great mystery of this field. I work with the people at the Extreme Universe Laboratory to design a mission which includes specifying the kind of instruments we need. In the days of the first discoveries of gamma ray bursts, people used old-fashioned scintillating materials, which were kind of clunky and primitive, and now people use very sophisticated semiconductor detectors, which can have all kinds of smart electronics and cell trigger and so forth and so on and so on. But they're much more sensitive and give us much more powerful in smaller packages. The Ultra-Fast Flash Observatory Pathfinder, which has this terrible acronym UFO, is an opportunity that we had from our colleagues at Moscow State University to have a small payload put on a satellite, and we had just a few years to do it, and we wanted to make a big impact in gamma ray bursts. No one knows about what the very first few seconds of a gamma ray burst look like in the optical. And to understand the gamma ray emission over here on this part of the spectrum, understand the optical emission over here on this part of the spectrum at the same time is very exciting, because you can ask questions like, do they vary together, do they vary differently? So our tiny little satellite, only tiny, tiny little 45 pounds, 20 kilograms, is going to actually be able to, within a second, look at the optical emission from a gamma ray burst. I learned a great deal from this workshop. In the first place, for all of us in the United States, the interplanetary network of gamma ray burst measurements is very famous, and one of the most important elements in it is called the CONUS satellite. And we had one of the original people who worked on it come here and talk about it. And that was really exciting to actually see him and talk about him. Russian experiment, we don't sort of learn much about it and don't know it personally, although it's very famous. The second thing is I learned from one of our Japanese colleagues, Toru Tanemori. I learned from him about his kind of new and very different kind of detector, which doesn't use kind of a stack of very dense materials to track gamma ray bursts, but rather a rarefied gas, very light instrument that could be possibly used for spaceflight, and is just a different way that I've thought about it. We really want to converge on making the smartest, cleverest, fastest, lightest, least expensive next generation instrument.